Welcome to our second webinar, second of three in this series. As I mentioned before, you may be new to this, but my name is Larry Reagan, and I'll be serving as your moderator for today's program. And I'd like to welcome you on behalf of Ariel Ambar and Punya Mishra from Arizona State. They are the primary PIs on this project. And if you've not had a chance to do it, I would encourage you to visit the website that is mentioned in your email several times. There's a lot of very, very good resources there for you to become familiar, including a brief video that we played during the first webinar. We're not going to repeat it today. That just gives you a little bit of a grounding. It's 2 minutes and 30 seconds. A little bit of introductory information about the webinar and the workshop. So we will use the same techniques and strategies as we did last time, and I'll get to those in a minute. But one of the comments in the chat group was learning more about the objectives of this webinar. So I've developed just a very short three that I'd like to share with you. Why are we doing these before the workshop? So the first objective is to really build sort of a shared knowledge base, a shared language that we use, a shared understanding of some of these concepts. As you know, we're using the lens of humanistic, meta, and foundational knowledge. What does that mean? How does that relate to what the end products are going to be? So the other is to really give you a grounding in what some of the expectations will be for the products that we're looking to generate, these curriculum maps, and some of the guidelines for the future substance of STEM education. And the third objective is to build community. And we do that by having you engage and having you interact as much as possible. And we're going to use the same strategies we did last time. Punya, you'll see his eyes intently reading down through the chat. He's going to be our chat moderator there. And one of the things that he does very nicely is take comments, and if they could be flipped into a Q&A, we'll ask you to do that and put those into the Q&A box, of which Ariel is going to be managing. And about halfway through the program, we make a bit of a switch and go to your questions. So we really want to get you engaged in the dialogue with our panelists and to really explore and understand these topics a bit more. So the last piece, and some of you heard us joking about homework, I'm going to ask Punya to mention. There is a small bit of homework here for the future. Punya?
Thanks, Larry. You always have to check down if you're muted or not. That's sort of the instinct that one has developed now. So thank you all for joining us today for the second webinar. As you know, that the webinars are actually just the stepping stones to the week-long sort of workshop and the work that we will be doing, and that work will be happening on our website. So you will be receiving an email from Ariel later today, which will give you a link to the survey, which we would appreciate your filling out, because that helps us get some feedback about how we can do this better. But it'll also have a link to a small piece of homework. And essentially what it is, you have to go onto the website, you log in, so we make sure that you can log into the system, because we want to keep the work that you're doing private for the duration of, when you're working on it. That should not be public. So that requires us to sort of make sure that you're authenticated and can get into the system. It's a very small, it should not take more than 5 to 10 minutes of your time, but it would be a great help if you could complete that by next Tuesday, because then that will allow us to see who could not get in and reach out to you individually to make sure that you have access to the system. And without further ado, back to you, Larry.
Thank you, Punya. That helps us deal with any kind of logistics issues. Ariel, before we let you and Punya go off screen, would you like to say hello to the group and welcome?
Sure. So welcome, everybody. We're very excited to have you. Hope you enjoyed the first webinar, which we thought went really, really well. And judging by the comments we got, aside from a few logistical things, people were very excited. So we're looking forward to yet another great webinar conversation here. And so thank you to both of our guests for joining us in advance. And thank you to all of you for coming.
Thanks, Ariel. Thanks, Punya. So just a quick recap, if you will, on Tuesday's session. Hopefully most of you were able to join us. We were looking at that first knowledge structure called Humanistic Knowledge with Richard Pitt and Katina Michaels. As you heard, they both spoke passionately about the need to broaden the lens of STEM education to encompass the human dimension and how we might do that. Richard spoke a lot about identity and group processes in this area, and in particular in the sort of the digital space. Katina really was looking at that intersection of technology and human beings, in particular around ethics. And I think gave us a great foundation for, and maybe the sequencing of this was really quite brilliant, of thinking about the human technology aspect first, which is the humanistic. So today, we're going to shift a little bit and look at the meta-cognitive dimension of the model. And we're going to be looking at learning theory and cognitive psychology. We have two prominent scholars with us. We're thrilled to have with us Candace Thiel and Elke Weber. And I'll introduce them a little bit more formal in a second. And then, as I mentioned, we'll be having the third webinar next Tuesday, where we'll be exploring foundation knowledge, which is often considered the stuff that we've sometimes perhaps over-focused on. So let me introduce our guest. Candace, I'm going to do you first. Candace Thiel, who's currently serving as a Director of Learning Science and Engineering at Amazon, is working with Amazon's Global Learning Development Team to scale and innovate workplace learning at Amazon. I'm not exactly sure what that means, Candace, but dang, that sounds exciting. Candace's research focuses at the intersection of how students learn and the role of technology in that teaching and learning process. I'm certain that we'll be seeing Candace's work not only in the Amazon world, but that's going to infiltrate and influence and impact education as a whole. It's wonderful to have you with us, Candace. Thank you. Elke is the Gerhard R. Adlinger Professor in Energy and Environment, Professor in Psychology and Public Affairs at Princeton. Elke's research explores the change process, and in particular, decision-making. I know we'd all like to think that decision-making is a predictable and measurable process, but okay, I suspect you're going to tell us it's probably anything but. But these two domains, how we learn and what we know about how people learn, and then to Elke's point about how we make decisions and why that skill set in particular is so important, not only in STEM education, but I would imagine in many different fields. So we've asked Elke and Candace to give us a little bit of a snapshot of their research areas as kind of a preface. And Elke, if you don't mind, I might start with you. Could you tell us what you're examining and what you're learning?
Absolutely. Thank you so much, Larry. So as you know by now, I'm a cognitive psychologist by training, and psychology is also, most of you know, is a science in most universities, but I've also worked with other social scientists and natural scientists most of my academic life in interdisciplinary, transdisciplinary settings and centers and groups, that some which I founded myself. And most of them have been designed to promote better individual and societal decisions related to climate change, or to sustainability, more broadly defined. So the title of our session today is Meta-Knowledge, and it lists the following concerns in its title or subtitle: how we learn, problem solving, critical thinking, and risk assessment. And all four of these topics actually are important questions in my own research agenda over the past 4 decades. And in particular, the first one, how we learn, and then the last one, risk assessment. So let me say a little bit about each of those, and then sort of also maybe more general comment on meta-knowledge. So let's start with how we learn. How we learn, of course, also includes what we remember, and then how we decide based on what we've learned and what we remember. Some of my research sort of goes under the name of decision modes, and it's basically designed to expand the set of processes that we typically think about by which people make decisions. So most of you think about decision making as some calculation-based process. We think about what are the outcomes, what are the odds, how far are they into the future. We should discount them a little bit if we don't get it right away. And we certainly do make decisions with our heads, if you want, in some sort of calculation, in some sort of cognitive way. But that's not the only way in which we make decisions. So we oftentimes make decisions with our hearts. We use our emotions. We use positive emotions, sort of curiosity, feelings of benefits. If it feels good, we want more, we go and explore. If it's scary, we back off. We have fight or flight responses. And oftentimes we don't necessarily even analyze those decisions. They happen quickly if they're based on emotions, because our emotions are hardwired. They're always there. And they're in some sense an early warning signal that either something is good to be exploited or bad to be avoided. And then the third way in which we make decisions is not just with our heads and with our hearts, but by the book. So we have standard operating procedures, we have rules of conduct, some of them are moral rules of conduct, social norms that we follow. And I guess sort of these voices, multiple voices, not in a schizophrenic sense, but in a good sense, are in our heads, and they sometimes agree with each other about the best course of conduct. And other times they disagree with each other. And then we have to sort of listen to them, learn to hear them, and also learn how to reconcile them. So we can, maybe in our discussion, we can talk about what the educational takeaway from that is. Then let me say something about the last topic, risk assessment. And so there, my research really has shown that perceptions of risk really matter. So we have to figure out sort of how somebody thinks about risk as an individual, as a group. And oftentimes, related to this point that I made about different modes of decision, oftentimes that is not necessarily by analysis. It's not necessarily risk as variance or risk as sort of negative probability of something bad happening, but oftentimes risk is a feeling. And there's been a lot of good work on that in the 1970s by some psychologists on psychological risk dimensions, identifying dread and feelings of being in control as drivers of perceptions of risk. And showing that these perceptions by the general public are oftentimes very different from the risk assessments by policy experts. So that explains expert novice differences. And also on top of that, their domain differences. So you might be very risk averse when it comes to financial decisions, but you go bungee jumping, which looks like a risk-taking behavior. And so a lot of my research has been trying to figure out how that can be, and is there such a thing as a risk attitude that actually is a characteristic of an individual, or not? Are these unstable? It turns out that it's a perception of risk that oftentimes vary, but that the attitude itself is actually quite stable for a given individual. So again, let's think about what is a teaching takeaway maybe later on. But I think maybe even just being aware of the fact that perception of risk is not equal to attitude towards risk, and that you have to sort of factor out the perceptions out of attitudes when you look at what people are doing. And also sort of a way of understanding why differences in perception or in attitudes come about. And as a result of that, maybe respecting the diversity in responses to a risky situation. Let me sort of finish by saying something more general about meta-knowledge. Oftentimes, sort of when we think about decision-making, critical thinking, we think about this in this rational, sort of calculation-based way that I alluded to earlier. So we think about rational choice. We have courses in our curriculum on rational choice, on critical thinking, on Bayesian updating, on logic, on the scientific method. And it's great, that having developed these principles, and these ways of processing is a huge evolutionary advantage that we have, beyond other animals. But those are really our aspirational goals, making decisions in that way. And human decision makers, certainly scientists are capable of making judgments and decisions that way. But that scientific mindset and the associated processes need to be taught and practiced. They do not come natural. And so one of the things that I've been looking at is sort of what does come natural, It's basically these, processes that are based on associations, that are based on similarity, that are based on associations with emotions, that are based on following rules of conduct that have been sort of shown by society to perhaps be better than individual utility maximization. So understanding this sort of whole range of other processes, I think is important to see to what extent it deviates. So the decisions that result from it deviate from quote unquote rational decisions, but also how they and rational decisions come about. And so understanding that we are at best boundedly rational, we have attentional capacity limitations, and many of you have seen this beautiful video by Chris Chabris on the gorilla and the basketball players that shows us that even when something is in full sight, we don't notice it because we're otherwise preoccupied. But yeah, we have these limitations, and therefore we have to basically allocate those scarce resources of attention and processing carefully. And how do we do that? And we typically do that by focusing on the here and now, on ourselves, on our families, on the present. And oftentimes, that is quite adaptive, but oftentimes also have to look further, especially in this more technologically challenging and complex times. We do have to sort of plan for the future. And then the question is, how do we do that? And so then the teaching takeaway from this more general point is that we can really help probably ourselves and others make better decisions if we are aware about the shortcuts that we use as a result of bounded rationality and the blind spots that we may show at times as a result. But that's not where we have to end, because there's also this big body of research that shows that we can redesign our decision environments in such a way that we can take these shortcuts and use them as processes, as mechanisms for the good, some sort of psychological jujitsu where focusing on the here and now and focusing on the losses that we typically do sort of actually result in better decisions. Sometimes people refer to that as choice architecture. I think sort of these lessons have been applied broadly and I think quite successfully to consumer decisions, to financial decisions. They haven't really been used very much in thinking about how we can apply them to science and STEM education. So I very much look forward to our conversations on that.
And we look forward to, that was marvelous. And we look forward to your helping us understand how do we take these concepts of how decisions are made and where and when and what are the methods that we might use to build those skill sets into the curriculum. So hold on to that thought. That was marvelous. Thank you so much, Elke, for that. Candace, now I know you're looking at the learning process and how we and in our society, what are the mechanisms of learning? And I know you're looking at sort of the environments that are optimal for that. Can you share a little bit of your work with us?
Sure. So as you stated, I'm currently at Amazon as the Director of Learning Science. And what I am studying there and building there are the infrastructure and processes to innovate and scale workplace learning for Amazon. So prior to coming to Amazon, I was an associate professor in the Graduate School of Education at Stanford University, and also on the interdepartmental faculty of neuroscience. And then prior to that, I was at Carnegie Mellon University, where I founded a project called the Open Learning Initiative. And the Open Learning Initiative started off as kind of a big combination research and practice project, where we were taking what we knew at the time about human learning and using that to inform the design of open web-based learning environments with the goal of making those learning environments openly available to anyone who just by gum wanted to learn statistics, because that's such a natural human drive. I just want to learn statistics. So the Hewlett Foundation recognized that natural human drive and funded us to build an open learning environment to teach introductory statistics to anyone in the world that had an internet connection. And that we started that work back in way before MOOCs. And so the approach that we were taking were very different than MOOCs. It was really thinking about how do people learn and how do we design a learning environment that would support someone to actually learn concepts of introductory statistics. We also did teach chemistry, physics, logic, causal reasoning, economics, many other subjects. And the way that we built those environments is we brought together teams of learning researchers with subject matter experts, with human-computer interaction experts, with learning designers, and everyone coming together to bring their particular area of expertise to bring to bear on how to build a learning environment that would be most effective to support human learning. That's when we first started building the instrumentation on those environments, because we realized that we would never know whether they were working or not, because the students who would be using them, we had no insight into whether they were learning or not. So we started to instrument those environments to collect the data from the learners' interactions and seeing if we could tell from those interactions whether or not they were learning. And then we could introduce different interventions into those interactions to conduct research in human learning. And so my areas of research quickly expanded from just studying human learning to studying the machine learning and the intersection of human learning and machine learning, which then led to these questions in building these kinds of environments. When getting into Elka's area, when you're thinking about decision making, one of the decisions that a learner or an instructor needs to make is an instructional differentiation decision. For this learner, at this point in time, what's the best thing to tell them, give them to do, etc., that will support them to move from their current state of knowledge to whatever their desired state is. And what are the features about the learner? What are the features about the thing that's being learned? And what are the features about the context in which that learning is occurring that would help us make a principled instructional differentiation decision? And so we started to essentially introduce experiments into this environment, and became a big research and practice environment. And we were funded by NSF for the Pittsburgh Science of Learning Center that used the Open Learning Initiative courses essentially as the research labs to study human learning. So from there, I went to Stanford, because most of that research, as you can probably tell by my discussion, was very much coming from a very cognitive or information processing model of human learning. And so going to Stanford, I was able to expand that research by collaborating with other colleagues who study other aspects of human learning. Some of the things which I know you discussed on Tuesday: how does a learner's identity and their identity in a particular context interact with the learning process? So there are many other, how does the learner's mindset, their beliefs about their own intelligence, their beliefs about their own abilities to learn interact with their actual ability to learn? So at Stanford, I was able to partner with colleagues there who study those various aspects of human learning to expand the research of the Open Learning Initiative. What I'm doing now at Amazon is essentially bringing that body of work to focus on workforce development. And I know there was so I want to, can I ask my question that I like to ask audiences? Because I'm really curious. Everyone's talking, especially now with COVID and everybody having to suddenly move online, which, you know, most faculty didn't want to do, but suddenly we've all been kind of forced to do that. And so, but even before that, people were really talking about that educational technology was going to fundamentally transform education and higher education. And I used to go out and talk with people a lot to understand, how do people think this transformation is going to happen? And usually I would get 3 answers. And so what I'd really like to do is just ask the open question here, but given that we have, I don't know, 80, 100 people, that's not going to work well. So I'm going to give you a choice and ask people to just kind of quickly vote in the chat which you think. So I'll give you the 3 choices, and then I'll say when you can vote, unless there's some voting mechanism on Zoom that I don't know about. Anyway, the 3 choices are, so the question is, what's the power of the technology that's going to transform higher education? And the 3 things that people usually respond are: one, access and convenience. If you have a device, you can learn anytime, anywhere. I mean, it's what COVID is forcing us to do, right? So that access and convenience is the big power. The second one is no. It's the simulation capability. That we can create learning experiences in a computer to have our students have experiences that are really hard to do in a classroom. For example, for the engineers in the group, you can have students build a bridge and then drive virtual cars across the bridge, and that falls down and nobody gets killed. But then they have an authentic experience that you can then teach from. So that simulation capability allows students to play all kinds of what if scenarios when they're trying to build their understanding of a complex domain. So the simulation capability is really the power. The third one, and this one was more recent, is that's total 20th century thinking. The real power of this technology is that it's not an individual person and a computer. It's a computer connected to a network. And so through that network, we can connect our learners to each other, to different experts, to different resources, to the world. So the real power of this technology is the connection. So those are your three choices: access and convenience, simulation, connection. So just quickly, oh look, we do have a vote.
I've launched a little poll here, so people can try to answer the question in the poll.
So see if you can answer the question in the poll. We'll just give you a moment. Tell me when we should reveal the poll.
And I know, Candace,
Well, still, entries are still coming in.
Okay.
talking to you that it's not as easy as saying all of the above, right? Which is my inclination to say all of the above.
Well, yeah, it's a forced choice activity. Can you speak a little bit about that? No. Because I think if we gave all of the above as an option, I would say everyone is going to say all of the above.
Yes, yeah.
Yeah. Okay. Do we have a distribution? Do we get?
Yes, I think we've reached stability. So I'm going to end the poll and.
Can you show us the distribution?
Share results. Let's see. Yes, we should be able to.
Yeah, there we go.
Everybody can see it.
Okay.
Yeah.
This is a pretty common distribution, and you can just say, is there anybody who wouldn't have answered all of the above if that had given you that as an option? Well, you can't answer me, but I'm going to assume a lot of people would. Is there anyone who would have answered none of the above? That none of those are really the power. You missed it, Candace. Usually I'd ask if there is, what is it? What did I miss? Well,
yeah,
I'll just.
If anybody would say none of the above, just put it in the chat. That would be fun.
I'll just. This is interesting. So I'll just say I would say none of the above, because while all of those things are really important, the real power of this technology that's going to transform education is what should I say? Amazon already figured out. It's what Google figured out. It's what Netflix figured out. The power of this technology is not designing all these incredible activities and just pushing them out to people. It's doing what we did in the Open Learning Initiative, which is we pushed it to the interface. Because in the interface, we can observe the learner. And we know that Amazon, Netflix, Google, they're observing us in the interfaces all the time. And they're doing it for a particular reason. They're doing it because they're trying to, well, I'll graciously say, they're trying to understand us better. In Amazon's case, they're trying to understand us better as consumers, each of us collectively and individually, so that they can be much more effective at targeting our needs as consumers. So you might say, okay, that's kind of creepy that you're talking about learning as consumption. I am not, but I'm talking about that same idea that if we push the learning activities to the interface and collect the data from those interactions, we can use those data to understand our learners better. Not just that we can understand the individual learner better, so that we can understand better that learner's needs and be able to target them better to help them learn. But we can also understand the learning process better. And so what I'm really focused on now is, given this affordance of the technology, we can all be essentially researchers and practitioners. So this old model of the learning researchers doing a bunch of lab experiments, coming up with principles, and then sending those out for all of you to implement, and then figure out that it doesn't really work when you try and implement it because the contextual variables weren't considered because we controlled for all of those. Rather, we can use this technology to create a new interaction between practice and research, where practitioners, as they are designing engaging learning experiences, are essentially creating little mini natural experiments. And we can collect massive amounts of data from those and model those data to try and infer some of those more interesting relationships between learners, features of the learner, features of the context, and features of the thing that is being learned. So I'll just stop there.
Thank you, Candace. Yeah, I wish you had a little more passion for your area there.
Sorry.
No, that's terrific. I wanted to go to Elke, though, and maybe make a connection. How does, in your mind, Elke, how does what Candace is describing of this pushing it to the interface influence what we know about how people make decisions? Is that at the interface where we observe the decision-making process, or does it go beyond that?
So I was actually, to answer your question in an oblique way, I was going to push back a little bit on Candace's fourth option, in the sense that I think the first three options that they described are motivations for the user, for the learner to use the interface. And so, because it gives them access to a network, to other people, it gives them access to simulations, it makes it more convenient for them. The fourth one that you mentioned is really a motivation for the designer of the learning system. The designer who has hypotheses about what will work, what can work, and who can now test them, because we have this instant ability to do A/B testing and to find out which hypotheses work out and which ones didn't get us anywhere. And I think those are very different populations. Now, you're right that sort of users in one context can also be designers in another context. And that gets us sort of very naturally to this idea about choice architecture. And in choice architecture, the decision environments we're in, on the one hand, we are the guinea pigs for them. We are the ones who get subjected to them, but we also are, in all of our environments, are oftentimes active architects. We decide how to tell our kids to go to bed. We decide how we address our students. We decide sort of how a message gets transmitted. So I think it's my pushback is that there are different classes of motivations for different actors, stakeholders in the process. But I think it's not just that one group is always one and the other group is always the other one.
Right, absolutely. And your last point is exactly my point. And also, even if the immediate benefit is to the learning designer, because then they can build better learning experiences.
Absolutely.
The ultimate beneficiary is the learner.
Yeah.
Because then that enables the learning designer to build that learning experience in a way that supports the learner better. And that's if you have a designer who's designing in your interest, benevolent. So I should say that and I've said this explicitly at Amazon as I'm building these systems for Amazon, that I start with some fundamental assumptions about the motivations of the learner and the motivations of the learning designer. And if those assumptions don't hold, then my system won't work. That's true. And the fundamental assumptions are, like, I assume, like the learning environments that I'm building are targeted at Amazon employees. And I'm assuming that Amazon employees are going to those learning environments because they want to build knowledge and capability that they need to build in order to play their role better. And that's their motivation. And I'll talk about, someone brought up the whole issue of data collection and privacy. And I'll talk about the guidelines that I use for responsible use of learner data, specifically to that. But the responsible use of learner data guidelines that I use require that we start from the assumption that the learner wants to build the knowledge and capabilities. And then we also start with the assumption that the people that are building the learning experiences are building the learning experiences, are trying to support people to build knowledge and capabilities. And it's only with those two assumptions that giving feedback to the learner about here are the knowledge and capabilities you're trying to build, here's our estimate of where you are in your trajectory toward building those capabilities, and here's some resources you could explore that might help you. That only makes sense if the learner's trying to make a decision about, I need to know where I am, I understand where I'm trying to get to, and I want to know what's the best path that will support me to get there. And so by the same token, for the learning designer, I'm giving them lots of feedback about, for the things that they have built, for which learners, under which conditions, does their environment seem to be supporting learning, and where specifically does it seem to not be supporting learning? And the idea there is if I can give them good enough insight, then they'll know where to target their next round of work to continuously improve that environment. But if we don't start with those two grounding assumptions that I've given, if that proves to be true, if the employee doesn't really want to build the knowledge and capabilities, or if the learning designer doesn't really care about helping someone learn something, then the system won't work. That's true.
Yeah, I'm watching the chat space, and it's kind of reflecting our conversation on Tuesday, and I'm going to go off script a little bit and see if I can connect some dots. One of the things that Richard and Katina were pretty passionate about in their conversation is understanding the nuances of how our educational systems react to and influence and impact people differently, classes of people, groups of people differently. So I've got it, and so I get sort of two questions, one for Candace, one for, okay, Candace, how do you accommodate for those differences? So it sounds like you're not building a V1, massive learning system that's going to serve everybody's needs. It has to be nuanced and such. So that's a question for you. And okay, I'd like to understand from you is, how does the diversity issue impact our decision-making process? It must have an influence on how we see and how we make decisions and such. And I think there's a connection in there that I'd like to explore, because as our teams go out and build these curriculum maps and such, we have to be thinking concretely of how do we build that skill set in our future learners, as our students coming out of STEM, how do they get that? So Candace, if I could start with you.
Sure. And I appreciate the comments in the chat, especially someone says access is racialized and classed, and systems will reflect our bias. I completely agree. And in fact, I will go so far as to say that all of our systems are built in a foundation of a culture that had an assumption of white supremacy. So one of the things we need to do in any system we're building is take a critical lens to what are the aspects of that system which actively support that structure, and what are the aspects, and how do we make sure that we shift the system in order to intentionally deconstruct that system. And one of the places that is true is one of the things that we do use is on my team, I have a large team. On my team, I have a bunch of ML scientists who are taking the data, and we're doing different ways of modeling, different approaches to modeling to make estimates about whether or not a learner has developed a particular set of knowledge and capabilities. But we recognize that if we're going to train our data on old data sets, that those data sets will have within them the bias that system had when the data set was created. So one of the advantages of using these ML models is they can expose patterns in our data, which we perhaps just as humans can't handle that many dimensions of complexity. But the models can show us a pattern. And then we can inspect that pattern and say, wow, we need to either weight the model differently to intentionally offset or balance that pattern, or we need to explore that pattern and understand it better so that we can root out the source of that pattern. But it's what I want to make sure people understand, I'm not advocating at all, is taking large data sets of learner data, training models on them, and then using that as the system that we're going to replicate, because all we will do then is instantiate the existing biases in our current system.
Candace, you used the word 2 times that I cued into, and that was the word intentional. And I'm thinking as we do project out and look at these models, that this becomes a skill set that we have to intentionally build into our system so that students understand that addressing bias in whatever we do is becoming aware of it.
Yeah, well, it's becoming aware of it and not feeling afraid or feeling bad about yourself, that's how your thought process works.
Yeah.
You know, I am racist.
Yeah.
I couldn't not be. I was raised in a racist culture. And so, but the other thing is I can't just stop saying, okay, I'm racist. So everyone live with that.
Right.
It's like, I'm racist. I think racism is wrong. So it's on me to be aware of that. My natural response, my first response might be racist. And so I have to inspect that and interrupt that and put energy and process into that to be able to not do that. Yeah. And it's a lifelong process. Mm-hmm. And I think that's going to be true for racism, probably for sexism in the sciences in particular. We have to really inspect not just our own attitudes, but our systems and structures that perpetuate that approach.
Mm-hmm. Lisette says, and I appreciate this, intentionality is the key, being aware and then acting upon it. Okay, can I go to you then with that follow-up question? How does the issues of diversity, of broadening thought process, how does that influence decision-making, risk-taking? And what do we do with that when we start to look at curriculum that we may be building out for the future of our STEM learners?
I think Candace sort of set up what I would say to your question very nicely, and making the distinction on the one hand between implicit racism, sexism, implicit bias, and intentional biases. The fact that these processes are lifelong conditioning. They're not going to disappear overnight. Yeah, as well-intentioned as we are, they will require exposure to more representative sets of experiences, to more representative sets of individuals, so that our categories shift in a more vertical direction, that our emotional responses to individuals, to situations shift. And we're all more comfortable with what we know than what we don't know. There are also sort of oftentimes sort of fears put out, sort of that are not justified at all, but nevertheless reverberate. So I think it is really a systematic and long-term process, and we have to sort of anticipate that things are not going to change overnight. But we can, I think, awareness of the fact that they're not going to shift overnight, and that our implicit processes might lag, can be overcome with more explicit awareness and corrections. So let me sort of take a little bit of a diversion to answer your question, which is, how do we make decisions in general? And I think when we prepped for the session a week or so ago, you mentioned query theory, which is this body of research where sort of I and my collaborator, Eric Johnson, have been trying to sort of summarize a whole bunch of insights about how we make decisions, how we come up with judgments that evolve around sort of basically sort of, if you're given the choice, do you want your one marshmallow now? Are you willing to wait sort of for 2 marshmallows in 20 minutes? How do you decide? And the general notion in query theory is that we generate alternatives for one option and for the other option. And if you generate more arguments for one, the balance goes down in that direction and you choose that alternative. So far, so good. Sounds all very rational, right? Well, turns out the $1 million question is that it really matters which alternative, or which person, let's say in an election context, or which person as a teacher who looks at the classroom of kids, who are raising their hands, which alternative do you consider first? Because all other things being equal, this gets back to limited attention. All other things being equal, you will generate more arguments for the first option you consider, because once you consider the first one, you think, okay, let me think what argues for that. You inhibit all arguments for all response competitors. And then as you now turn to alternative B, because its advantages had been inhibited a split second ago, they have a harder time coming to the surface. So the $1,000,000 question in most contexts is which option you consider first. And of course, that's where it matters whether you're comfortable with an individual, when that person is similar to you or dissimilar to you, whether or not sort of your emotions are right. So I think sort of all of these inherent prejudices and biases that we have, emotional and cognitive and otherwise, sort of come into play about where we allocate our attention. And that's why the woman in the room doesn't get hurt until the guy in the room makes the same argument sort of 3 seconds later. So our attention is very much guided by our biases and prejudices. Again, as Candice was saying, it might take a while to get around it, but we can, I think, consciously try to remedy those implicit biases.
Okay, in some of your research, which I found really fascinating, you talk about change is hard. And in looking at sort of the change process, we were talking a little bit earlier about, the first decision-making process might be the path of least resistance, the habit. How do we help our learners break those, at least recognize the habit of the way we think? As Candice said, I was raised this way, this was the culture, and it's really hard. I mean, she's raised a point we have to be intentional, which takes cognitive load, it takes work. How do we do that in an educational setting? Are there exercises and things that we can do, strategies, techniques that we can do with our students to practice that, to make it a natural part of decision making?
Really good question, and I think this is my students did this debates this in lab meetings. Sort of how many ways are there to break habits? Or how many times do you have to actually pay someone to do something in a different way, or entice them by external incentives to do something differently before it becomes automatic and you do it that way? That is certainly sort of, and the answer is yes. I mean, I think sort of practicing, asking people to change perspective, have role-playing exercises where you sort of immerse yourself in a different identity, in a different way of seeing things, certainly can help. It also can help to just take the status quo away. Nobody likes change because what we know, it's the devil we know, as opposed to sort of all the different things that can go wrong when you go to a different alternative. There's a certain comfort level. Also automatic habits happen automatically. We don't even think about we have a decision. We just sort of automatically latch onto the option that we've used so many times before. If somebody recommends sort of an alternative, sort of that seems to be an implicit endorsement. But in situations where somebody takes the alternative that we have been doing for a while away, like right now with COVID, there's a tremendous opportunity because all the old ways in which we have been conducting our lives have mostly disappeared. And as Candice said earlier, sort of now we basically, as a teacher, you have no alternative but to figure out how this new technology works. And so I think sometimes, as an enlightened dictator, and by Candice's definitions, we are dealing with enlightened dictators in our conversation here. Paternalism doesn't have to be a dirty word, and taking certain options that might have been tried and true under different circumstances and in different environments, but are no longer functional, just taking them off the table is not such a bad idea.
Interesting, thank you. Candice, any thoughts, reflections to that, what Elke provided?
No, I agree with everything Elke said. I mean, one of the things, when I think about it practically, what can we do? Think about what are those observable patterns or behaviors that you want to interrupt. And then this is where I do think that technology-mediated environments, learning environments, can play a big role. For example, let's say you have a goal that you want people to simply be, we're talking about interrupting bias around race or gender. You want people to even be able to have a conversation about race or gender bias, which is uncomfortable for a lot of white people. And part of that comes from the fear, I think, from a lot of white people, that I'm going to say something and someone's going to think I'm racist. And I'm not racist because I equate being racist with being a bad person. And so they'll just misunderstand me. So that's a fear. And the other fear is, and I don't want to hurt somebody. I don't want to say something racist that's stupid and actually hurt somebody. So, and I think those two fears come together to make people hesitant to actually engage in conversations where they could actually make progress, interrupting their thought processes. But here's a place where a technology-mediated learning environment would be perfect, because what Elke was talking about, to change patterns, what you need is practice. What we know is you will just do it's that kind of energy efficiency thing. You'll do what you know how to do. Paying attention takes energy. So if you have an opportunity to practice engaging in conversations about race, and you can say the things and then get feedback from a system that doesn't make you feel embarrassed or ashamed or whatever, and then understand why is the way that you said that potentially reflecting the way you don't want to be thinking, and here's a different way of thinking about it, then you could practice. You could practice running those different perspectives and ways of speaking about it in a safe environment. And then that would set you up to possibly feel more comfortable engaging in conversations with human people.
This is, it's fascinating in its complexity.
Can I add one sort of angle to this?
Yeah, go ahead.
I think so. Yeah, the idea of these controlled learning environments, I think, are very important, because they give us so many tools. And so if you go back for a second to query theory and the importance of which options get considered first, if our natural inclination, let's say in a job search, is to sort of look first at the candidates who are more similar to us, and then sort of in the end, we also look at some minority candidates, because they're on the list. Well, change the system in such a way that sort of the people who have been traditionally underrepresented get presented first in the committee meeting, and they get discussed first. When everybody's attention is still fresh, makes a huge difference. We see this on election ballots. We see this in all sorts of contexts. Primacy really matters.
Yes, thank you. Thank you. Okay. Ariel, I'm going to go to you and ask you to channel, I like to say, any questions there from the Q&A?
Sure, yeah. So, I mean, this has been very nice because you guys have been monitoring the chat. So many of the questions in the Q&A reflect the chat. We've addressed them. But there's one question, one of the first questions asked by Daryl Rieno. It's a really good question and pivots us a little bit away into broader societal questions. So the way he asked it is regarding the politicization of science or anti-science. How do we acknowledge this human component of science, all these biases, everything we've been talking about, right? That really goes into real decision-making and learning. How do we acknowledge that's important in science and STEM without degrading non-scientists? And I would add to that also students, STEM students' perceptions of science as an important factor in decision-making, right? Because the value we have societally and that we ascribe to science is that science provides us all this information, it lets us be objective and so on and so forth. But once we acknowledge that there's all these very subjective, very human factors in how we learn, perceive, even tackle scientific questions to begin with, how do we not then corrode the broader societal perception and the students' perceptions, right, of what they're even engaged in? And I realize it's a big question, philosophical question. So, but it's a very good, important, good question.
I guess the way I think about it is all these things that we're talking about is observation, is ways that I make meaning of things that I can observe outside of me. And so my own individual decision making, the information input that I have is my own individual observation and my own individual experience to make meaning out of that observation. In a sort of what I'm proposing is what the scientific process is, and using the scientific process to inform learning environments. It is giving me access to, in a structured, agreed upon way, to not just my observations, but hundreds of thousands of other observers' observations. And so that is the information input that I can balance with all these other things, my emotions, etc., to make a decision. So that having that essentially collective structured way of collective observation as an information source to inform my decision is critical, even when we recognize that my decisions are going to be made with these other heart and context variables that Elke talks about. I don't know, Elke?
Yeah, let me build on that. So I think what Candice is talking about is, on the one hand, the strength of seeing something with your own eyes. Seeing is believing. And we find that in the case of climate change, for example, so people who have personal experience with extreme weather events, for example, regardless of their political persuasion and ideology, are much more likely to believe that this is an important and serious phenomenon we should do something about. So that's true. But then Candice also points out the limitation of just having your own experience, and how much more evidentially power there is in sort of having basically personal experience multiplied by a million times, and summarized in some statistical way. And maybe convincing people of that power is to involve them more in citizen science. The idea that sort of, yes, you can take your personal impression of something in your personal collection of data, but then put it together with other people that in these networks that that we have evolved these days, and see how it accumulates. So see that accumulation actually happening in real time. So that helps. But then the other point maybe to make it gets back to this notion that we make decisions not just with our heads, but also with our hearts and by the book. And so reminding people of the fact, or acknowledging that yes, scientists sort of might be primarily trained to do things in this calculation-based and seemingly objective way, but that's not the way sort of scientists themselves or the general public makes decisions, and that emotions do matter. And that doing things by some moral rule of conduct, because your church says this, or because your professionals says this, also matters, and that these things actually can be in conflict, and oftentimes in our society are in conflict. And then as a society, in some participatory fashion, we have to figure out which of these different sort of pieces of evidence that point us towards A or B or C in this particular context should carry more weight. And that is a political process, it's a social process. There's sort of no way around conflict, but acknowledging that these other sources of information exist, these other voices are there, and they're not necessarily invalid, that we just have to come to some consensus about how much weight to put on each one might be a step forward.
I think that's a fascinating observation of sort of considering the moral dimension to how we make decisions, how we assess risk and such, in the curriculum. Like how do we bring that into a part of the conversation? It's not just about the scientific science, the data. It's also about the interpretation and what we do with that information. And you're suggesting, I think, okay, correct me if I'm wrong, that those two things have to be connected. They have to be married. We have to consider the data in light of the fact that we are human beings with biases and such.
We have to consider that we're training then students in STEM for a world in which that's the way STEM operates, right? Where it's not all rational decision making. And I think, I'm going, my own commentary. I think we tend to not pay attention to that in the design of the STEM programs. Right? We don't teach our chemistry majors or our physics majors that just because you may be correct in your technical analysis of the chemistry or physics or biology of a situation, that's the way that society is going to defer to you as an authority, right? And is going to value your very rational scientific analysis over other value systems that are coming to play in a complex decision that involves balancing these sorts of things. And I don't have an answer to this. I don't think, I'm sure you don't either, but if you have any commentary to offer, it'd be great. How we should be doing that in STEM degree programs, in a whether it's a computer science program or a chemistry program. What is the way that we bring that kind of sensibility, that kind of awareness that the values of science are only a piece of the value set that's going on in society? How do we do that? If you agree that that's sort of the correct analysis, and if you don't have an answer, that's fine. Or if you have thoughts, it'd be great to hear them.
Well, I would think sort of case studies would be a good way of doing it. So as you're teaching a particular sort of method, or a particular sort of topic in chemistry, find an issue that actually is somewhat contentious in society. I mean, it's easy enough to do this in genetics and genetic engineering, climate change and geoengineering, but come up with an issue where there is contention, and then sort of have the students talk about sort of why is that? What does the science say? Is the science unambiguous, or is there actually some sort of disagreement? Is it a function of sort of how the science is being used for solutions, and it's not the science, but it's the solution that's unacceptable, or the meta principle that the solution is brought about by bigger government, and it's the size of the government, that maybe the agency could be transferred to private companies if that is more acceptable. But I think case studies might be a good way of sort of surfacing what exactly the bone of contention is, because oftentimes the bone of contention is not what's publicly stated, but it's something that's somewhat deeper.
I would also add that one of the, when we were reading the academic disciplines of our participants, I think I remember reading someone here is in history and philosophy of science. So I would encourage scientists to tap into their colleagues who do study the history and philosophy of science and talk about how to bring that dimension into your science curriculum. Because what's also true is the way that we think about science and the role that it plays in decision making isn't persistent over time. There's a reason there's a history and philosophy of science, that the philosophy of science and the history of science obviously changes over time. So I think even just presenting to students that notion and having them have a sense of how philosophy of science, or the different aspects of different sciences, the philosophies undergirding them, have changed over time, could also help them understand the current context better.
It reminds me of the old adage, it's not either or, right? It's and, but, what if? And so looking at how do we encompass, how do we create future scientists, if you will, who are open to the idea that these humanistic dimensions of who we are influence how we make decisions, how we build systems, and so forth. Ariel, can I go to you and see if there's another question that you would want to pose from the Q&A?
Actually, I was.
Candace has something she wants to say.
Oh, go ahead, Candace.
That I saw in the chat that I wanted to address.
Please go ahead.
Someone a while back basically asked the question, which I get asked a lot, which is why I want to answer it. Are you proposing that we replace faculty with computers? Basically, is the option. And when I used to talk a lot about education and technology, there was actually a headline in, I think, the Chronicle of Higher Education or Inside Higher Education or something like that, that a big picture of me standing up on a mountain someplace in San Francisco with my arms crossed. And the title was, "She's Trying to Replace Us with Computers." And this was from the Open Learning Initiative work. And my first response to that used to be, well, frankly, if the computer systems I'm building any faculty member that can be replaced by a computer system I'm building should be. And that didn't quite get the response I was looking for when I'd say that to faculty groups, because what I meant was that what the role of a faculty member is, or an expert in a field is, in supporting people to learn and become part of that field, is so much richer than anything I can do with a controlled learning environment, that if that's all you're doing as a faculty member, you're actually not doing your job. But I also acknowledge that what faculty are being asked to do these days, which is to take large numbers of students, because class sizes, especially in STEM, are getting bigger and bigger and bigger, take large numbers of students who have huge variability in their background knowledge, in their skills, in the goals, the reasons they're even in your classroom. And you're supposed to get that huge number and huge diverse number of students from all the places they are to a certain level of understanding and knowledge in your discipline in 10 to 15 weeks. That's not doable with the tools and things that were given to do that. It's an unrealistic expectation to put on faculty. So what I'm trying to think about is, how do we build better tools to support both the faculty and the learners to help them achieve that goal. And that's like back what Elke was saying when I was talking about the, what's the affordance of the technology, that I'm talking about two different groups. In this case, you could make the same argument that I'm talking about not just benefiting students, but how does the technology really benefit the faculty in trying to help them, support them to do the teaching role that they've been asked to do in this untenable situation. Mm-hmm. So absolutely not replace faculty. All the systems that we're building should augment humans and human decision making.
There's also a lot of discussion on in the chat about sort of STEM faculty not always sort of feeling that they either have the expertise or sort of the inclination to play this broader role of putting their science into a broader social context. I think the point of that is, first of all, not everybody needs to do that. And secondly, sort of that oftentimes sort of doing these things in a team fashion. For instance, we have a program in the School of International and Public Affairs where we sort of train PhD level scientists about the policy implications of their current research, and they do that sort of as in a 1-year add-on that sort of happens in parallel. Well, the same thing can happen in high schools, right? The same thing can happen at the university level, where sort of maybe you try to coordinate a science course with a humanities course, where you have specialists in both areas, but you're just sort of talking for a given year about a common theme and a common topic. So it doesn't have to be done by each STEM instructor. It just the fact that these things should happen in parallel at some level is important.
So on that note, and I'm watching our time, I'd like to ask each of you to share maybe a piece of advice or a piece of wisdom. As you're aware, our teams are going to be addressing specific problems of the future of STEM, the STEM curriculum. And they're going to be doing that more or less in around a specific discipline domain. What advice, Candace, I'll maybe start with you, in order to get them to think about integrating what we know about how we learn in that environment, what advice would you have for them?
Okay, I guess when you're designing your learning experiences, that students learn, you can't make someone learn something. Someone learns something by attempting to essentially perform, and then the richness and the appropriateness of the feedback that they get, and then an opportunity to try it again. They have to construct their own knowledge. So in whatever the learning experiences that you are designing in the workshop, think about it not from the instructor perspective of what do I want to tell them, but think from the perspective of when they finish this learning experience, what is it? What's the knowledge and capabilities I'm hoping that they will have developed? And then what kinds of activities, and those activities could be listening to me, but what kind of activities, either engaging with each other or engaging with materials or whatever, is going to have the highest probability that they will engage in a process that will allow them to develop that knowledge or that capability. And then what kind of feedback mechanism do I need to make sure is in place so that they have sort of goal-directed and supported practice. And
I'm going to suspect, Candace, you would say that may be technology augmented, and it may not be. These are concepts that play off of each other. That it's not an either-or scenario.
Right. I mean, you don't have to do the kinds of things I'm talking about designing are certainly easier to do if you have a technology-mediated environment, because then you can design the activity in the environment, have the learner act, and then give the learner immediate feedback, and then allow them to practice again to incorporate that feedback. So I always find that's the easy. And then you can also collect data from all the learners who did it to see how well the activity that you designed actually supported people to develop the knowledge and capability you wanted them to develop. So I actually think that's the easiest way to develop it, but you can do those kinds of activities in a human-based system without having it technology mediated.
Okay, thank you, thank you. Okay, can I go to you? What advice or wisdom can you share with our participants in how to address the decision-making process, how to develop that skill that expertise with our students, and understanding the whole factor of the risk assessment.
So building on what Candice just said, I think sort of it's important to differentiate between motivation to learn something and the actual process, you know, of getting information across. And I think the general advice from me would be that maybe some of the things we talked about provides you with a broader sense about sort of how different learners differ from each other. Yeah, and so we used to talk about, you know, sort of how much, you know, sort of preparation do they have. But I think what we talked about today is, you know, sort of some people are more analytic, some people might be more affect based, some people might sort of come in with a set of sort of rules about how certain things should happen, so be aware that you're dealing with different types of students. Students who have different motivations to learn this particular topic, sort of learn how to present the advantages of learning this topic in different ways. And then I think sort of, you know, the main point that I really want to emphasize is testing. It used to be hard to evaluate, you know, sort of educational methods, you know, educational hypotheses that we have. But I think these days, by being online, and now more than ever, you know, with COVID, the world is online. We have such a tremendous opportunity to test between hypotheses and get feedback. Yes, you might have the best model about how your students differ, but yeah, try it out and see what kind of feedback you get. Yeah, and different methods, how successful they are. Try it out, because yeah, A/B testing is there, and we should use it as much as possible.
Yeah. Yeah, take your research, all the scientists on this call, take your scientific brain and focus it on your teaching practice, and think about every time you're teaching something, you are essentially testing a hypothesis. You hypothesize that this is what your students know now, this is what you want them to know, and this thing I'm about to make them do is going to help them move from where they currently are to where I'm trying to get them to go. And that's a testable empirical hypothesis.
Well, you two have given us a lot to consider, and a big challenge, frankly, as we look forward, because your domains are challenging, and it's not impossible, but I'll go back to the word intentional. I think as we're mapping things out for the future, we have to be thinking about how do we integrate these concepts in there. Candice and Elke, thank you so much for taking time to be with us today. It's been marvelous and so much rich information here. I'd like to ask Aryo or Punya if there are any final thoughts or comments they'd like to share.
Punya, would you like to go first?
Sure. Again, thank you very much for joining us today. And as you can see from the chat, really engaged discussion on all of these issues. And what's wonderful about it is that these are what are hard, difficult, knotty problems, right? And so there is not going to be one answer to it, but I think what these conversations have done is raise sort of the broader issues and themes that our teams will have to really grapple with. Because at the end of the day, you want to create a program, and there are these constraints of institutional constraints, of domain constraints, but having these conversations, I think, sets the stage in a really powerful way. And so that's, I think, really exciting for us to see the work that will emerge from all these people who have been so wonderfully engaged in all the themes and ideas and topics that came up in this conversation. So thank you, Candice. Thank you, Elke. That was awesome.
Thank you. It was fun. Bye-bye.
Yeah, and thanks very much. Yeah, there's nothing to add to that. So thank you very, very much for your time. That was an incredible, great chat, great challenges.